right, so the first bit of evidence we have is just observation of star systems. So this is one of the reasons I have been encouraging people to do any stargazing you possibly can. North County's got some wonderful stargazing spots, and you generally want to get a little further away from the coast. I mean, of course, one of the best stargazing spots on the planet is the summit of Mount Palomar, and the Palomar Mountains tend to be remarkably dark given how close they are to major population centers, and generally boast very clear skies at night. Well, I like to observe this. And so from the observation of night skies, we have gotten quite a number of phenomenon. And if you want to see a little bit of what that looks like, in the videos for the week, let me close the week 1 module since that is there. You can go through this gigapixels of Andromeda. And what I encourage people to do is try to count the stars here. What a student told me this morning was they stopped counting at about 100. I'm impressed they got that far. I generally am like blown away after about 12, and just in this scene here. So point being, we have plenty of stars in the sky, even though not all of them are like the sun. There is enough of them that are similar to the sun that are of different ages that we can kind of infer many of the stages of our sun's evolution by looking at things from the sky. The first piece of evidence we put down here is the first pieces of evidence are observation of other stars. And this is getting better and better as we go forward in time. Like, we're actually starting to see young solar systems in early stages of formation through some of the telescope technology. And this is one of those things that, like, gets me excited about the world, because we need things that get us excited. Like, seriously, when we put our minds together, work together on cool science, and have a society that truly appreciates science, we get better things. And right now, we got some pretty kick-awesome scientists. I know a few of them, a lot more I don't know. We start to get clues as to who we are. This is a beautiful thing. I'll just say that much. Other piece of evidence is comets and asteroids. And again, you may wonder, why are we talking about these things in an oceanography course? Because up 10 years ago, we did not know where Earth's oceans came from. Like, we literally didn't know. We had several hypotheses. One of the hypotheses was that what you're looking at here, this rotating body in the lower left corner, this is a comet that we recently landed a probe on about 5 years ago. We used to think, or at least it was definitely a hypothesis, that the oceans were created because multiple water-rich comets crashed into Earth. We know now that after landing on this comet, taking samples of this comet and analyzing those samples, the spaceship analyzed the samples while in the comet, it wasn't going to fly back. We have found that, indeed, the comet is, the water in that comet looks absolutely nothing like water in the ocean. So this is evidence, believe it or not, against comets being the source of ocean water. We also have things like this. This is a meteorite. This is a rather unusual one. They're not unheard of. This is a palisite. It's a meteorite made of iron and olivine. These are rocks you find in the core and mantle, respectively, all kind of mixed together. And what's cool is we know these rocks are in Earth's core and interior, but apparently these minerals are also found in space rocks, suggesting that all of Earth came out of one chemical soup. So evidence part 2.
Cool rock.
Yeah, asteroids, meteors, and comets. And what's cool is for the first homework, you are going to be actually looking at several combinations of asteroids, meteors, and comets, and looking at some of the data from that we've gotten from those, and trying to think a little bit about what that data means. And I'm going to be pretty open-ended. Generally, my assignments, if you're making good faith effort to try to understand the stuff and communicate the understanding, you're likely to get full credit. If you make a mistake or a misinterpretation, I'll let you know, because I'm a little less generous on the exams, but yeah, but asteroids, meteors, and comets, this is another form of evidence for this, for how we know how our Earth came to be. Third one is chemistry of Earth. Earth, by looking at other star systems and these asteroids, meteors, and comets, we can make some inferences. Then, of course, we have physical models. And so all this together leads us towards nebular hypothesis. So let's take a look at some nebula. Do a Google image search for these. Here we go. Here's one of my favorites. This is the famous Horsehead Nebula. And so you look at this thing, you want to look, let's take a moment. We're going to